I am going to start a new video series in which I look at two-factor studies. A little explanation of what we mean by two-factor studies. In the previous video series, we continued our discussion of multiple linear regression, except that we did it with a categorical explanatory variable, and that variable was called a factor. So now we're going to look at two categorical explanatory variables, that is, two factors. As always with multiple linear regression, we continue with a single quantitative response variable. So we'll have one quantitative response variable and two categorical explanatory variables. Each of those explanatory variables are called factors, thus two-factor studies. This is commonly known as two-factor analysis of variance, although as I pointed out in the last video series, we're still doing multiple linear regression, and even when we have quantitative explanatory variables, we do analysis of variance. So I think that the label is a little bit misleading, but it is traditional, and so you should know it. When someone says that they're doing two-factor analysis of variance, what they mean is that they're going to do multiple linear regression using two categorical explanatory variables and a quantitative response variable. Now, when we had two explanatory factors in the past in which they were both quantitative, we talked about the possibility of interaction or even perhaps moderation. The same is true when we have two categorical explanatory variables. There is the potential that these explanatory variables interact with each other in terms of their effects on the quantitative response variable, and it is even possible that one variable moderates the effects of the other variables. So that is something that we have to add new to the equation when we're dealing with categorical explanatory variables. It is just as though we were doing it with two quantitative variables. The principles are all the same, but the analysis techniques can be a little different and look a little different. So we're going to need to review interaction again and talk about it in this new context of categorical explanatory variables. A study that includes more than one categorical explanatory variable is called a multi-factor study, and each explanatory variable is known as a factor. Here's an example. We have factors that influence feelings of inclusion in the freshman year of college. One factor might be whether or not the student has a connection with an older student mentor. Another factor might be whether or not there is faculty participation in the residence hall life of that student. An interaction effect is the effect of two or more factors that cannot be explained by each individual factor. Interaction effects are present when the effect of one factor is not consistent across levels of the other factor. For example, perhaps the effect that faculty participation in residence hall life has on a freshman student is not as pronounced when the freshman has an older student mentor. In that case, these two explanatory variables are interacting with each other in terms of their effect or influence on the quantitative response variable, the feelings of inclusion. Let's take a look at another example that I'm going to use as a running example throughout this series, and we're going to use it to actually see how to do the analysis. These are the tooth growth data. C.I. Bliss obtained and publicized the data from a study originally conducted by E.W. Crampton. The response is the length of odontoblast, that is, the cells responsible for tooth growth, in 60 guinea pigs, each receiving one of three dose levels of vitamin C, 0.5, 1, and 2 milligrams, with one of two delivery methods, orange juice or an aqueous solution of ascorbic acid. No guinea pig received a dose of 0, as they would acquire scurvy at that dose. Now let's look at the variables here. The first variable, length, is odontoblast length in microns, and it is going to be our response variable. Notice that it is quantitative. The next variable is supplement type. We have two different types of supplements. That is, two different ways of providing the dose of vitamin C to the guinea pig. Either we'll do it through ascorbic acid or we'll do it through orange juice. Those are the two different ways of getting the doses, one of the three types of doses or possible doses, into the guinea pigs. And the third variable is dose. Now this requires some explanation here, because if you think of dose in milligrams per day, that's a quantitative variable, and indeed it is. There are three possible ways that we could treat a quantitative variable when we're analyzing data. Most of the time, we're going to want to leave it in its quantitative form. Sometimes we could treat it as an ordinal variable. That is, I could say low, medium, and high doses, in which medium is higher than low, high is higher than medium, high is also higher than low. That is, there is an order, but we're ignoring the quantity. Remember that quantitative variables can always be changed to categorical variables, and in this case, I'm talking about changing it to an ordered categorical variable. The third option is to treat these as unordered categories. Yes, low, medium, and high seems to be naturally ordered, but we could treat it in the analysis as though it was unordered. There's nothing to say that we can't treat low as different from medium and medium as different from high without indicating the particular order for these variables. And indeed, that's how we're going to do the analysis now. So you might ask, why are we going to do the analysis that way when in fact we could treat the variable as either ordinal or treat the variable as quantitative? The answer is simply that I'm teaching you right now with two categorical explanatory variables, and we're going to have them as unordered categorical explanatory variables. I'm actually not going to deal with ordinal data in this particular class. I save that for my non-parametric statistics course, so if you're interested in how to analyze ordinal data using those methods, you could watch the videos from that particular course. But I'm going to only treat this now as unordered categorical. Now, in real research, why might we do that? One reason for doing that would be if we had unreliable measurement quantitatively, but we could reliably put individuals into categories. Now, in this case, with these data, that's not the case because we're talking about milligrams. Milligrams is a physical amount, and we can measure that quite accurately and quite reliably. And it is valid because it's talking about some volume that we have. But there are many times in behavioral and social research in which you are measuring an underlying construct, such as achievement or aptitude or emotional states. And those can be difficult to measure reliably. If you can do so, if you can measure reliably and quantitatively, then the typical rule of thumb, I say typical because this isn't always the case, but typically you'll want to keep the data as quantitative in order to get the most power. On the other hand, if you are having a difficult time either with reliability or the validity of measuring an underlying construct, but you can do so if you used a ordered or unordered categorical variable, then you might actually have an advantage of using that reliable categorical measurement here in quotes, because now we're switching from a measurement to putting into categories. You might actually have better analysis, better results, and more valid results if you're doing it with a type of categorization rather than a quantitative measurement due to the increased reliability that you'll get of putting individuals into categories. So that is not the reason we're doing that here. We could surely leave this as quantitative. The reason we're doing it here is because I'm going to teach you with two explanatory categorical variables. And we actually have not in this video series or in this class, we have not yet encountered a situation where we have one categorical and one quantitative explanatory variable. If you're wondering if that's coming down the road, the answer is yes. We will encounter that. We will take on a categorical variable and a quantitative variable at the same time. But we're not there yet, so we're going to treat 0.5, 1.0, and 2.0 as unordered categorical values. We'll call them low, medium, and high, but we're not even going to worry about the ordering of medium above low and high above median. It will still allow you to learn the techniques that we will use when we have naturally occurring unordered categories, such as what we have here with supplement type. There is no reason to put orange juice above ascorbic acid or vice versa. They're just two unordered categories. That's the way that we're going to treat the dosage as well. So with those preliminaries out of the way, I'm going to end this video. And in the next, we'll start looking at how to analyze interaction effects for two explanatory variables. Why interaction? Because if we're doing an exploratory analysis, such as what we're conducting here, the first thing you want to do is look to see if there's an interaction. If you've been watching the past videos, you know why that is. Because if there is an interaction, it doesn't make sense to talk about the effects of each of the individual variables because those effects vary depending upon the levels of the other variable. Remember that interaction is when you have to answer the question, what is the effect of the variable, with it depends. What does it depend on? It depends upon what level we have of the other variable. So that is why in the next video, we'll start with interaction and looking at the interaction, but this time, unlike in the past, when we used quantitative explanatory variables, we'll look at the interaction of two categorical explanatory variables and that interaction effect on a response variable.